Recently, I came across a pretty interesting AI video, an AI digital human MV titled White Pikachu released by AI Talk. The results look quite impressive, however, its implementation mainly relies on proprietary large models, namely Gmang and Klang. I wanted to challenge myself and see if I could recreate an MV using ComfyUI while relying solely on open-source models as much as possible. This is my final product. The total length is 3 minutes and 9 seconds, but I'll just showcase some clips here. The full version is already released as a separate video. Let's break down the MV production process and see what functionalities we need to achieve. Since this is a music video, the first step, of course, is to prepare a song. Any song will do. Next, we need to invite a virtual singer. We'll need images of her from different angles while ensuring consistency. She also needs to sing, her lip sync must be accurate. If we only have shots of the singer, the video might feel monotonous. So, we also need to insert some aesthetically consistent transition shots. To keep things simple, I won't consider complex editing for now. We just need to piece together all the materials in sequence to create a basic MV. Sounds like a clear process, right? No more talking, let's go step by step. By the way, all the workflows involved will be linked in the description. Technically, we can choose any song, pop hits, nostalgic classics, anime themes, anything goes. But to avoid copyright issues, I decided to generate a song using AI. I first explored open-source models and tried Yue and DiffRhythm in ComfyUI, but unfortunately, the results weren't quite there. They just didn't feel right in the MV. In the end, I gave in and used Suno. I provided just one prompt and used the free credits to generate this song. It's a bit of a shame, but hopefully, better and more powerful open-source models will emerge in the future. With the song ready, it's time to hire a singer. Since the song is a soft, nostalgic ballad, the main character should be an elegant, vintage-style female singer. I asked GPT to generate a prompt for her. I tried generating images directly using the Flux model. I inserted the prompt into the Flux text-to-image workflow, adjusted the resolution for a landscape format, and ran it. The results weren't bad, but they didn't quite meet my expectations. It's not that the model didn't create a pretty character, but I had high standards. I wanted the singer to have a more distinct and special aura. So, I needed to find a LoRA. After searching, I found a LoRA filled with vintage aesthetics, author, MyArt. I downloaded it to the LoRA's directory, went back to the workflow, loaded the LoRA, added the relevant trigger words, and ran it. The result was great, it really had the right atmosphere. I generated a few more images using this prompt, and they all looked good. But we can't just use these images directly to generate the video. While they may look similar at first glance, a closer look reveals inconsistencies. We wouldn't want our MV's main character to suddenly switch necklaces mid-song, right? The simplest way to maintain character consistency across multiple images is to use in-context LoRA. The official documentation mentions its applications in film storyboard generation, portrait photography, portrait illustration, and other fields. It can generate multiple images in one go while ensuring consistent character features. LoRA also supports image conditional generation, meaning it can reference a specific part of an existing image when generating new ones. Combined with the Flux film model, it allows for fun tricks like one-click outfit changes. However, its effectiveness for character reference is somewhat unstable. I didn't want to spend too much time on trial and error, so I opted for the more stable portrait photography function. LoRA consists of 10 different models, each serving a different purpose. I downloaded the portrait photography model and placed it in the LoRA directory. Next, I modified the previous workflow to load this LoRA and adjusted the prompt accordingly. The official prompt template looks like this. The first part describes the overall scene, specifying the total number of images, the theme, and the setting. The latter part describes each image individually. I decided to generate 4 images in a grid layout, capturing medium shots of the character from the left and right, a front-facing medium shot, and a close-up. So, my prompt was structured like this. To make the images look more like MV visuals, I want each image to be close to a 16:9 landscape format. Compared to Sonic and Wan, Flux doesn't put as much pressure on image generation, so we can set a resolution larger than the video size. Let's go with 1920 by 1088, since 1080 isn't possible. This means each image in the grid will be 960 by 544. However, when using Sonic to generate videos, this aspect ratio will consume more VRAM compared to 1:1. If you're experimenting, you might want to start with 512 by 512 first. Set the steps to 50 to ensure the model retains as much detail as possible when rendering the image. No need to adjust other parameters, just click Run. After a short wait, we get a 2x2 grid of images. Looking at them, you can see that the character, makeup, white dress, necklace, and earrings are all consistent. If you're not satisfied with the character's appearance, you can keep generating until you get a satisfactory set. I'll proceed with this set for the demonstration. In ComfyUI, the Rave plugin's image grid decompose node is specifically designed to split grid images like this. Setting x_dim to 2 will divide it into 4, 2x2, images, while setting it to 3 would produce 9 images. Other parameters can remain unchanged. RS is just the random seed. Click Run, and we now have 4 960 by 544 images of the same character from different angles. To make her sing in ComfyUI, the most developed and simplest lip-syncing solution is Sonic. Typically, we split the lyrics into several segments, pairing different angles of the character with each part and generating multiple short clips that are later combined. Of course, if you have plenty of VRAM and time, you could generate a full video for each image and then mix them in editing. For those with limited VRAM, running shorter segments at a time is an option, but make sure not to cut in the middle of a sentence. Otherwise, the transition will feel abrupt and unnatural. For my MV, I divided the lyrics accordingly. However, since recording consumes a lot of resources, I'll just generate a 2-second clip as a demonstration. In the Sonic workflow, select the song, then in the Load Audio section, set the starting time to 5 seconds and duration to 2 seconds. Since we're limiting the audio length through loading, we can set duration to an arbitrarily large number, like 1000. Load a singer's image, then check the min_resolution parameter. It should be smaller than our image's resolution. Otherwise, Sonic will use a very rough upscaling method, leading to pixelation. I set mine to 512. If you find it too slow or if your VRAM gets maxed out, you can lower it to 448, 384, or even 320. Lip sync is the key focus here. If you want higher quality output, you can upscale the video using Wan2.1 for secondary sampling. In Sonic Sampler, the dynamic_scale parameter controls motion intensity. Since this is a gentle song, 0.5 is enough. Rename the file for easier saving, then click Run. Because I was also recording with Focus C, which consumed a lot of resources, my VRAM got fully occupied, making the process take much longer than usual. Normally, an RTX 4080 handles this easily. If you run into issues, just lower min_resolution. In the end, I got this video clip. Checking the lip sync, it looks good. Using the same method, I swapped different images and audio segments to generate multiple clips of the character singing. Now, let's create some transition shots. Since the main character is singing in a room, we'll stick with the same vintage aesthetic and generate some indoor scenes that match the song's theme. Returning to the previous Flux image generation workflow, the vintage LoRA is essential this time, as it ensures a consistent style. The in-context LoRA can be removed since it's primarily for portrait photography. Generating objects with it is still possible, but there's a high chance of white edges appearing, which would require extra cropping. Now, let's change the prompt to a close-up shot of playing the piano. Since I'll be using the 480p model later, I'll adjust the resolution to 832 by 480. For a single image instead of a grid, 20 steps should be enough. Click Run. And this image looks great. In this workflow, simply changing the prompt allows you to generate plenty of transition shots. Now, let's bring the images to life and turn them into video. Load a Wan2.1 image to video workflow. This time, I'll use the GuffQ6_K model, so the model loading node needs to be switched to the corresponding UNet loader, GGUF. For other models, remember to use their local paths. Upload the previously generated piano playing image. Since the resolution is already 832 by 480, update the width and height accordingly. This aspect ratio is close to Sonic's final output, so merging everything into the final video won't be an issue. The usual frame count is 81, but anything between 33 and 129 works fine. For demonstration purposes, I'll generate only 33 frames. Keep the step count at 20. If you want more detail, increasing it to 40 is fine too. The default frame rate is 16 FPS, but in practice, it doesn't matter much since Wan generates transition shots unrelated to audio. You can adjust the speed or interpolate frames as needed. Wan doesn't require complex prompts, just describe the scene and the intended action. My prompt already includes playing the piano, so I don't need to change it. However, if you want explicit camera movements like zooming out or panning, or specific actions like waving or snapping fingers, you'll need to add them manually. Click Run. Based on past experience, my recording software takes up VRAM. I only have 16 GB available, which significantly slows down generation, so I'll turn it off and restart recording after the process finishes. Now, let's check the results. This run took just over 9 minutes. The piano playing animation looks good. Previewing it. It seems to sync perfectly with the piano sound in the music. If you're not satisfied with a single result, you can generate multiple versions. The same process applies to other transition shots, so I won't go through each one. Now that all the assets are ready, the final step is merging them. At first, I wasn't sure how to organize everything, so I turned to a generalist AI model for help. I fed it the lyrics, in SRT format, which includes timestamps, and asked for guidance on structuring the music video. Not only did it provide a clear editing logic, but it also generated a detailed timeline. I used this as a base, added subtitles, made a few adjustments, and completed the final MV. Summary. A music video consists of music plus singer plus lip sync plus transition shots. For this project, I used Suno to write and compose the song, used Flux with LoRA to generate multiple angle images of the singer, used Sonic for lip syncing, used Wan2.1 to generate transition shots from images to video, ran the entire process smoothly on a 16 GB VRAM setup. However, as technology evolves or based on personal preference, any part of this workflow can be replaced with different models as long as they serve the same function. For example, if I used HeyGen, which requires more resources, for singing videos, I would replace both Flux and Sonic. Current limitations. Resolution constraints. The highest native output is 720p, and increasing resolution requires more time and VRAM. It's best to upscale separately. Limited motion and camera control in singing segments. Sonic only takes images as input and doesn't support prompt-based motion control. I'll continue exploring and refining this workflow with new technologies. I'd love to hear your suggestions. That's it for today's video. The models, plugins, and workflow details are in the description. See you next time.